Okay, shall we start, Kalyan and others?
Yes, sir.
Okay, good morning to everyone. The today's class is different. Uh, as we know, all have been discussed about the 3D printing in first module itself. We have been discussed about the 3D technology and 3D printing. So, in the name of additive manufacturing technology. So, before we can use to call it as a 3D printing. Before that, we can use to call it as a prototype printing. Thereafter, 3D printing. Now, the technical word term is changed from the 3D printing into the additive manufacturing printing. So everything we know already. So we take a much time, and we have been discuss about the first module. I think so. The thing is now today we need to discuss the what we have gone what we have been gone through the in first module or in plus classes about the 3D technology. Theoretically, you know very well about the 3D printing. Theoretically, we have been discussed in thoroughly, and I think so. We all know about what exactly the 3D printing, how it works, so what will be the principle, and what are the parameters we need to take, and their applications also. A lot of applications we have been discussed. Their raw materials for the 3D printing also we have been discussed in the while we are discussing about the 3D printing, right? But the thing is, what we have been gone through the theoretical aspects or theoretical things. Based on the theoretical aspects, today we need to discuss some practical things. How the practical activities are carried out in the 3D printing, right? So through this we have a opportunity, we can able to understand how the practically these 3D machines are works through this virtual lab. This is a well designed virtual lab from the NITK Surathkal. So this is a opportunity, we can take a utilization of this virtual lab so that we can understand how our 3D printings are works practically. You can get an idea through virtually. Am I audible properly, everybody?
Yes.
Hello, please kindly mute your mic. This is the kind request. Please kindly mute your mic, please. Yes, I'm audible properly. Hello.
Yes, sir, you are.
Yes, thank you, Kalyan. See, the main agenda or main aim of the today's class is to understand how the 3D printings are works, at least by virtually, how practically these 3D machines are works, the what are the practical activities we can able to carry, what are the practical activities, how they are processed by simulation. We can able to understand, that's it. At least we have get an idea about how these 3D printings all works. Unless we are not having these practical simulations and how the practically these machines are works, that whatever the theory part will be the imaginary things in our mind. Only we can go on through the theory. We, oh, this is like this, that is like this, that will become this side, and this will become this side, and this will be the deposition and the slicing will be happens. All these things are imaginary part in our mind, unless we are not having the practical experience. But this is an opportunity. Here we have we can able to understand through this simulations lab how these 3D printings are works, right? So everybody listen carefully and watch carefully how these 3D printings are works through a simulation. Now I can able to show you how these 3D machines are work by simulation videos. Through the simulation video I can able to show you, and also meanwhile I will we all together discuss. Already we have been gone through this in first module. Let's discuss we all together about the theory parts and parameters and working principle. Everything we will discuss meanwhile while watching the simulation process. Okay, shall we start? Shall we start, everybody? Please, are you there? Can you hear me?
Yes, sir. Yes, sir.
Yes, yes,
Yes,
yes.
sir.
Yes, we can go through the simulation process one by one now. So this is the well-designed virtual lab from NITK Surathkal. So here, as we can able to see a 3D printing virtual simulation lab, right? So here we have an introduction about this 3D printing virtual lab, as well the main objective of this lab, 3D printing virtual lab, and the list of the experiments, as well the targeted audience or target audience who can understand, who can study these things, who can able to gain the knowledge. So that is what targeted audience or target audience, and some assignments and feedbacks is there. Now let's start with the introduction. So what the how these labs we can able to introduce, or how they are introducing these 3D virtual labs. The welcome to the 3D printing virtual simulation lab. The 3D printing or additive manufacturing, as I told you, the earlier we can use to call it is in 3D printing. Now it is the technical term, it will be a change. Now we can call it as an additive manufacturing process. Is a process of making a three-dimensional solid objects. Obviously, we have been discussed the aim of this 3D printing is to produce the three-dimensional objects, such as many a number of machine elements, right? The real-time applications, not just for the model. For real-time applications, we can able to produce the 3D objects through this 3D printing. The solid objects from a digital file. The creation of a 3D printing object is achieved using the additive process. See, once again I will clear you that what exactly the additive process are. Additive process means here the addition of materials, those materials in the form of powders. This is the main aim of the 3D printing. The 3D printing is only to allow the powder form of the material. That will not allow solid and inbillets or ingots as like our traditional ways. This 3D printing is only to allow the raw materials which are in the form of powders. Hence, this process, the main principle of this process is additive process. By adding the number of or amount of powders, adding by layer, that is going to add the powder materials. Hence, this process becomes additive process. In an additive process, an object is created by, that's what, laying down the successive layer of materials until the object is created. As I explained, this is as it is. This process, additive means this process is going to add the raw materials layer by layer, the down successively layers of materials until the object is created. What we are expecting, the desired shape and size, till that this machine is adding the materials layer by layer. So each of these layers can be seen as a thinly sliced cross section of the object. Yes, everything we have been discussed. The material is very thin layer of thin slicing layers, one by one. That will be the build. So we can call it is a build up process. So layer will be a build from the platform. That one layer to make takes 100 layers and 1000 layers, because we have to get, or we need to finish what we are expecting, the desired shape of the component. Till that, the layer by layer materials are thin sliced layer by layer material slicing over the platform. And that the 3D printing is the opposite of subtractive manufacturing. Subtractive manufacturing means, as we can take an example as like our traditional, such as such as machining, drilling, shaping, and sometimes castings also. These are all the subtractive. Best example for the subtractive manufacturing, that is what cutting, drilling, and lathe machine is the best example. So this is the opposite to these such kinds of the processes, which are cutting, so hollowing, so out of the pieces of metal or plastic, so with engines of milling machines. That's what already I have told. All these are the subtractive of machining methods or manufacturing methods. This 3D is dead opposite of these processes. The 3D printing enables you to produce the complex shapes using the less materials than the traditional manufacturing methods. Already we have discussed the main advantage of this 3D printing is that to reduce the input cost or to minimize the waste of material, right? Let's go on to the now next we are move on to the objectives. See, let's see the objective. So objective, what is the main objective of this 3D printing simulation lab, or is 3D printing technology? The main objective of this technology, the students will be able to identify and describe the function of different parts of the 3D printers. The second objective is that the students will be able to use the simulation and assembly of the different parts of 3D printer. The third objective is that the students will able to realize the operation of the 3D printer for different parameters given by the students, and can check the effect of the different parameters on the performance of the printer. Yes, however, we are changing the different parameters. So how these parameters are attributes, or how these parameters are caused to the each and every process, that you need to check. The fourth objective is the students will be able to build a given 3D printer by using the different parts available with the students. This will be help them to learn the assembly without actually so uh, destructing the parts. And the last one is that the students will be able to answer the questions related to the part functioning and the assembly of the 3D printer. Yes, this is the main objectives of this virtual lab. I think once you gone and once you understand all these process and its virtual labs, I think you may able to understand thoroughly about the 3D printing, what exactly it is. The why I am focusing much for this 3D printing, because the uh, next manufacturing generation will depending upon this 3D printing technology. Let's start the list of the experiments. Yes, am I audible properly, everybody?
Yes, sir.
Yes, now we will look into the list of experiments which are here, we have here in our virtual lab. So here so the fused deposition metal. This is the kind of 3D printing already we have been discussed in the first module. So just I am glancing the things here. This is the anatomy of the 3D printing machines. This is the Cartesian 3D printing machines and the polar 3D printing machine and delta 3D printing machine. So later we will discuss about all these things, right? Because just it is an autonomy, and the Cartesian and polar delta different that is the different arrangements, the Cartesian arrangements, polar arrangements. Already we have gone through all these things, so I will not take much time to waste on this. I'm not ready to invest my time on these things. These things already we have been discussed directly. Our aim is to understand how the simulation process is works, because already we have gone through theoretically all these things. Now I'm coming to directly simulation of stereolithography process. I hope you know about the stereolithography. Stereolithography is the first invented 3D technology or 3D concept by Charles Hull. That also you know, right? The first class is the beginning class of this additive manufacturing. I have been told you about overview about the 3D printing, including meanwhile we have already discussed the history of this 3D printing. The stereolithography is the first invented 3D machine by Charles Hull. Now let's move on to how this stereolithography is works by we can able to understand by simulation process. Yes, go to the simulation, right? Before going to the simulation, I would like to tell something about the procedure for this simulation, how we can properly simulate this particular stereolithography. Here they are giving some instructions, or else we can follow some procedures. So click on the vat. You know very well, vat means a container or a bath, or sometimes it just look like an crucible or a furnace. Like vat is a bath container. So the vat, please mute your mic. It's a kind request. It's a common sense. How many times uh, let it be, no problem. So here the first step is that first procedure is that click on the VAT. So you can able to see that VAT portion, that or sometimes something they are writing the VAT, or something they are showing some VAT image. Just you can click on the VAT. VAT will be displayed on the left side of the screen. This is the first step. And second procedure is that click on the laser beam setup. There will be the availability, or there will be the indication. I think it is that laser beam setup. Just then you can apparatus. Once you click on that laser beam button, then the apparatus used for the laser beam will be displayed on the screen. The third step is to click on the button on resin polymer. Then the polymer resin will be filled into the vat. Immediately, this will be the simulation. Now click on the button of the platform, then the support platform will be added into the vat. Later you can click on the start process. This is what the start of the process. The process will begins. After the process is complete, click on the stop process to view the product generated using the SLA process. Okay, let's start. Let's start the simulation. Yes. Yes, according to the procedure, here we have a VAT. Now we need to click on the VAT button. Okay, let me to click on the button on VAT. Yes, here you can able to see the display over the screen. Yes, this is the VAT, right? Or container, or it is the bath. Okay, the next step is to click on the button on laser beam setup. Yes, now once we click on this VAT button, now the VAT is coming here. This is what we can call it is a bed or platform or container. This container is filled by the raw materials. Now in the second step we need to set the laser beams. Yes, click on the button of laser beams. Now the laser beam will displayed on the screen. Now these laser beams are ready to scan the raw materials which is exposed to the laser beam, right? When this materials are come across or this laser is traces the raw materials, that whatever the required shape will be generated in the material. All right, now we are arranging the laser beams. Now that's next step. Now I'm taking the resin polymers, because we need to, because the stereolithography, just that one more thing you should keep it in mind. The first stereolithography is only that process is able to produce the polymer components. Also we can call the stereolithography as a liquid polymer resin system. Hope you understand. This is one more name we can use to call it is a liquid polymer system. This process is only able to produce the 3D objects which are only made by the polymer materials. This is not suitable for the metallic materials. Hence, the name we can use to call it is a polymer resin process. Now we need to build the polymer resins into the bath or vat. Yes. Now once we click on the resin bath, here that entire bath is completely filled by the liquid. Yes, we can call this a liquid polymer. In the two both the sides that are both the side we have a vat or container. That container now is filled by the resin polymer. Hope you understand, everybody. Are you there?
Yes, sir.
Yes, I think it is clear. I think it is now. Once this resin bath is once the resin polymer is completely filled into the vat, now we will move on to the next platform because we need a platform. Whatever that 3D object or 3D image is generated from the platform, we have to make ensure that a proper platform over that our 3D print will be built layer by layer. Right now we'll select the platform. Yes, here there will be the platform. Here we can able to see the display of the platform so over the resin bath. Now the our 3D image is will be built over this platform. So that is by layer. Now I'm coming to hope you understand. Once I click on the button on the platform, now the platform is displayed in the resin bath. Now I move on to the next process, the start the process. Now everything is ready. Now the bath is ready, means vat is ready. That vat is completely filled by the polymer resin. Now our platform is also ready. Our scanning laser beams are also ready for working. Now only we need to start the process. Once we start the process, how this process works you only can see with your eyes. Yes, now once again start the button. Yes, let's we can see the how the simulation process works. The same way the 3D actual 3D printing is also works. Right. Let me to explain now what happens. Okay, see the platform is now moving down. Right, see the platform is moves down. The amount of raw material will come up. Once the amount of raw material is come up, so this is the carrier platform, or this is the amount liquid carrier, or it will maintain the required thickness of the resin plate. Once this device or this this device is maintained the required thickness of the polymer resin, immediately the laser is scans. Once the laser is scanned, this will be cured and becomes hard. Then that will goes up. Again amount of liquid resin will comes up. This is the blade or doctor blade will maintain the required thickness. Once this process is done, the laser is traces this material. Only this portion laser will be a traces. Now once that laser is this liquid is traced by the laser, hence it becomes cured, means it becomes dry, then it goes down. Again this process will keep on continue. The layer by layer, the thin layer of layer by layer polymer will cured, get down, cured and get down, cured and get down. However the platform is also moves down. Now we will get this is our 3D printing is generating here. Now here up to here the 3D printing is generated. So see you can the way we are getting the 3D print. This is the solid part or cured or hard polymer it is by the small amount of heat generated by the laser. Hope you understand how this process works. Say yes or no. How can I know you are in the meeting, right? Kalyan,
Yes, sir.
Yes, sir. We
Kalyan
can
and
understand.
others, you can understand now. Yes, let's see. can see once again. This is the laser beam. This is the we can blade or doctor blade. This will maintain the thickness of the polymer resin. How this plasma moves down, the amount of liquid will be come up. Hence, this is exposed to the laser. The laser traces the only the required area, required cross section will be traces. This will not traces unevenly. What we are expecting the desired shape, that area only traced by the laser beam. Laser will not take the beyond that limit. What we are giving the parameters, what we are setting the parameters based on that only that required portion will be scanned. And so once it's scanned, this becomes dry and cube. Yes. Now I will stop this process. Once I will stop this process, what we can able to see, let's see. Yes, layered part. So this is we can able to see. Yes, once I click on the stop button, so this is what our ready part. Now it is only plain part is there. Now you can design this like this and like this. Any type of the design you can so give. So based on that, this laser will be works. Now the laser is just traces. Now we will get the some just C type of the structure, right? If you want to give something design here, so that is done by the laser. What happens, laser will only traces this portion and this portion will not traces. Again, it is just like a liquid, only trace portion becomes solid. So by curing action you can get different shapes and sizes. How the portion is scanned by the laser, that same portion will be dried out, hence we can get the required shape and size of the 3D product. Here the straight portion is there, small thin sheet like the simple forming it is. Now it is plain 3D object is now formed. If you want to give any different shapes, you can able to do the different shapes and sizes. It's clear. This process is very simple because this is the first invented stereolithography. This process is restricted to manufacture the only the polymer components. Okay. Now we'll look into the post test and pre-test are there. Just we will carry these two tests so that you can understand better. One test we will carry, the post test we will carry out. Pre-test before the process. We have been discussed the much things of the theoretically. No need to take the pre-test if we have a sufficient time. So once again we will take the another classes. The post test is very important because we all together now we are simulating this process. The how we are able to answer these questions, that we will check ourselves. That is what self-evaluation. Now I will take the post test. Yes. Which file format is used for storing the information of the surface, including the structure and color? DWG dot documents HTML or STL file. Tell me, already this we have been discussed in the first module itself. Please guess the answer. If you know the correct answer, you can tell me the correct answer, or else you can guess the answer so that we can get the correct answer later. Huh? Come on, quick.
STL file.
100% right. Nice. SLA technique is based on the principle of fused deposition materials, polymerization of photosensitive resin, or extrusion of the molten plastics, or bonding of the materials. Just only we have gone through the principle of the stereolithography. SLA means stereolithography. Huh? Here just only we finish.
Sir, extrusion of molten plastic.
Extrusion. What do you mean by extrusion, dear?
No, sir. Fusion deposition.
Fuse deposition means material. Fuse deposition materials means fuse deposition means we need to fuse that. Fuse that means we need to melt that. See, this is what polymerization of
Sir, B
photosynthesis.
set.
Yes, because I told you that now SLA process is only suitable for polymer materials, the polymerization process, right? Let it be. So this is my guess is B.